Hi, thank you so much, everyone, for joining our panel discussion at GTC 2021. This one is the rising impact of AI, data science, and sports. It's a very exciting topic. I'm really happy to have Rob here, as well as my good friend from HP, Lenny Isler. Lenny, if you'd like to give a brief introduction.
Thanks, Jeff. My name is Lenny Isler, and I'm the Business Development Manager for Data Science and AI in North America. And as Jeff likes to say, I'm definitely powered by Z, and everything that we'll talk about today is powered by Z. And most importantly, we'll be talking about one of our flagship data science workstations, our Z8G4, as well as one of our flagship data science notebooks, our HP Studio G7. And with that, I'd like to introduce one of HP and NVIDIA's Kaggle ambassadors, our three-time Grandmaster, as everybody at HP, and especially within Z by HP likes to call him, our rock star, Rob Mulla. Rob, would you like to
That's
introduce yourself?
that's quite an intro, Lenny. Thank you. I don't know if I'd consider myself a rock star, but I'm very happy to be here and to specifically to talk about sports and data science in sports because I think it's a really exciting area. Being an HP ambassador has been great. The two machines that you showed in the last slide are what I use daily, and they make everything I do so much easier, and I love them. So other than that, I'm a data scientist with a strange road to where I am now. I started out in electrical engineering. I've worked in hospitality. I've worked in the power industry. I've worked in pharmaceuticals. And recently I transitioned to a job where I'm with sports data full time. So it's really a dream for me. And I'm so happy to be here.
Hey, well, we're really happy to have you here, Rob. And Lenny, thank you so much for bringing this to GTC. So when I think of like Lenny Isler powered by Z, I always have the monster truck voice, powered by Z. I didn't do it right, but that's what's going on in my mind. I think everyone cares about that, but even more so, I think everyone cares about data science and sports. Hopefully, everyone here is a data scientist or a sports fanatic or both. And some people might not really see how do the two go together. And it's like data science, it's just not used in sports to fuel competition between professional players, right? There's a whole host of things it does. It
Yeah.
plays a key role in improving the game quality, fan experience, and really player safety. And we're really grateful to have Rob here to kind of explain more of what's happening in sports. And what we want to do is start with March Madness. I know it's April, but March Madness has been on the top of everyone's mind. So, Rob, if you can kind of share, how you applied some of your data science techniques to help March Madness experience.
Yeah, definitely, Jeff. I think exactly what you were saying before about how people think sports, they think data, and what immediately comes to mind are statistics, the things that you see on the screen about how passer ratings, those sort of things. But we've really seen a revolution, especially in sports with tracking data, but also in sports like basketball, where we have now not only what percentage of players shooting at, but where are they taking their shots? Where are things happening on the court or on the field? And it's really awesome as a data scientist to have these types of data sets. So last year, for the last few years, Kaggle has been hosting March Madness competitions, but last year they had an analytics competition along with that, where they asked people to do more interaction with the data and to come up with some novel ideas. And initially, this slide kind of shows initially what you want to do is you want to see all this data on the court or on the field that you're used to seeing it on. So that was one of the first tasks I really took on there was creating this court that I could then overlay data on and visualize, because it's with sports data, it's so powerful to be able to see it. And I think any sports fan, when they see the data on the court that they're used to seeing it, it really speaks to them. You could tell some really interesting stories. So there's a lot of stuff I did with that competition. I don't know if you want to show the next slide, but
Yeah, so walk us through some of these things. I see the shot selection by group, so walk us through some of the things that you learned here.
yeah, so some of the techniques that we use in data science, commonly unsupervised techniques like clustering can be applied to sports data and really find some interesting things. So the way I attacked this competition was, instead of taking the standard positions that you think about in basketball, forward, guard, center, just taking all the data about all the players and letting the algorithm cluster them into groups and seeing what it came up with. So this is a machine learning algorithms, different groups of players. And to visualize the differences between the players, I'm showing where they take their shots. So you can see, I gave them their names, but the 3-point specialist, the shot takers, these guys are taking shots at a lot of 3-pointers. And then they're kind of found these clusters of groups of the paint dominators, the skilled bigs. These guys are playing more defensive or under the rim. So I thought it was really cool. I didn't know what was going to come out when I threw all this data into this algorithm, but the result was really something I think novel and exciting as a data scientist and as a sports
fan. As a sports fan, this is really interesting. And I played basketball throughout school, and I was generally a forward, but I would probably fall under that ball distributor type of personality from what the machine learned. Jeff, I'm interested, are you the skilled big or the paint dominator out of this group here?
It really depends on the day of the week, and my Wheaties or not.
And probably how much coffee you had too, right?
Yeah, I'm off of coffee, so so definitely I can't afford to get that amped up anymore. But Lenny, this is pretty exciting, right? And Rob, I like that this is a novel approach, right? So, where do you envision this type of technique really impacting the game, both on the player side, the coaching side, or just the spectator side?
Yeah, I think it from all those different areas you mentioned, it's going to have an impact. I think we've already seen it in sports like football, or even with the graphics that are on the game broadcast, you can see a lot more data being shown, and a lot more interesting information that has slowly kind of crept into the broadcast that we're starting to notice more now. And it's really, I think, enhanced the way that we view the games. For player safety, it's huge, because if you know where injuries are occurring or how they're situations that they're occurring, nobody wants an injury in any sport. That's what we all want to avoid, and no one likes seeing that. So if there can be ways to use the data to isolate why those things happen, I think that's huge. And then, like you were saying, if I was one of these 5, I'd probably just be a 6 group that's just all black, because there's no shots that I would ever make, because I'm not a good athlete. But I think those people that are athletes want to use this data to improve the type of athletes they are. And we know Lance Armstrong or other, cyclists, and use all this data that they collect about themselves, how their aerodynamics, all this stuff, to optimize how well they are. And I think that's going to start showing even more than it already is in other sports.
Absolutely. And what's really fascinating by what you've done here is it's a novel approach. I could see it on the spectator side, as it's going to be a fun thing to watch. I could actually see this being shown in breakaway clips during games. But most importantly, what you mentioned, Rob, is player safety. And I think that's what's paramount, right? Everything that you look in professional sports, it's really about how to keep the players safe and their longevity in their career, and have a graceful exit from their career. So I'm curious about, this type of approach is something that could be interesting all the way down to high school level, college, professional level, really to help protect the players and really nurture them as they're growing in their career as a professional athlete.
Yeah. And I think in this slide, you see I showed the different clusters of these groups that the algorithm found in terms of, I think it's rebounds and the points they're taking. But similar things could be done for injury prevention, or for trying to diversify a team lineup. And just like you're saying, that's what I think what we're moving towards. And there's a lot of novel things out there that have yet to be discovered. And that's the exciting thing as a data scientist, is you get to do things that you don't necessarily know will work, but no one else has done it before because the data just simply wasn't available. So it's really exciting to be a part of this time in sports and data.
Yeah, absolutely. Could you maybe expand a little bit more on your workflow and maybe tell us a little bit of the journey of the data? What data did you bring in to build this graph and what that workflow looked like?
So I'm a Python guy. I like to code in
Okay.
Python. I like to use my Z workstation for the heavy lifting jobs that I do, and then my studio book when I'm on the run, or if I'm doing jobs that don't require as much horsepower, although it already has a bunch of horsepower in it. But I usually want to see the data first, and that's why that first slide I showed you was creating the basketball court.
Yeah, Rob, this is a really amazing chart. What I'd like to do is take a pause and have you unpack a little bit more information about your process. What type of data you use, the journey of bringing that data into your life cycle and your workflow. Are you working in Python, and what frameworks and libraries you're using, and what tools you use?
Yeah, absolutely. I'm definitely a Python guy. Everything I code in is Python, and I am using my ZBook and my Z8 workstation. Z8 for all the heavy lifting, deep learning stuff. But I think that the most important thing in my workflow is always just to visualize the data first. So the first slide where I was showing how I plotted the court, that's what I want to do first, is see all the data in different ways. And I use Matplotlib a lot. I use Seaborn. There's a lot of packages in Python and in R that you can use to do that. But just visualizing it is usually my first step in the process, for sure.
That's great. Do you want to move to the next slide?
Yeah, so this is just speaking of that, this is just another way to visualize this shot taking attempts and then also shots made. This I think uses I used a Seaborn package in the back end, but given the raw data that we have about each player, you can kind of get a heat map. And to any basketball fan, you kind of see, okay, this guy's taking a lot of shots, but there's also a lot of activity under the rim. So,
yeah, absolutely.
Very interesting.
And then just another example of how you might plot the data. So we're given for the men's and women's regular season all of the information about when turnovers were taken, where on the court they were, all this rich information, and just plotting it out is a good way to start. So this may not be the most informative thing, but to start as a data scientist is a good place to maybe start asking questions about the data. And without that court plot, it wouldn't be possible. So
that's pretty fascinating, right? Because it's a huge part of the game when you see, the turnover and the location of that turnover. And I can see this extending out to where, where on the location you have a turnover versus that resulting in scores, right? Or injury for a player, right? Maybe if you're underneath the hoop, there might be a higher probability of catching an elbow versus, maybe mid-court, maybe there's a higher probability of converting that into a basket.
Exactly. And that's what I like so much about sports and data science, is that you can ask these questions that as a fan, I think all of us have, and then you can go right to the data and see if those hypotheses are true. So just what you said, I'm already thinking we could code that up. We could see if it works. And that's the awesome thing about having all this data at your hands.
Yeah, it really is. And it's amazing, Rob, when you visualize it, because once you do something meaningful with the data and you ask one question, that opens the door to many other things that are meaningful that can be posed with the data. And
yeah.
So I'm kind of curious too, as far as the source of this data, do you see from an IoT perspective that are we going to be getting more and more types of data input, maybe from tracking on people's shoes, from, the actual equipment, are we going to be able to get more insight as IoT expands?
Yeah, I mean, I think it's only going to become more and more, and you're going to see a lot of data coming out of sports at the professional level, at the collegiate level. But I also think that there are going to be markets for even non-pro athletes using different sensors and things to record how they're doing. I don't know if you guys use Strava or any of those other apps to track how you're doing. I mean, there's so much rich data that you can just track from yourself.
Yeah, I could definitely see, just the average person like ourselves using Strava to, track our exercise, but we have full-time jobs. We're not full-time athletes. So that small amount of time that we do have to exercise, using data to make sure that we maximize that exercise as well as stay safe, I think are things that, the average person can take advantage of from, data in sports as well.
Yeah, absolutely. I kind of see this as something really, to your point, Rob, is that, in the professional level, absolutely, this has a lot of meaning, but if you think from a parental level, right, when you have grade school kids, K through 12, who are learning sports, I see access to more data really helping them in their, balancing sports and academia, deciding whether they need to pursue the course in sports, probably even out with recruiting, but primarily around the parents. I see more parents probably having access, if you have an 8-year-old or a 10-year-old playing soccer or hockey or any type of sport where there could be types of concussion, where there's now data that the parents can have that can help them decide, is my kid on the right team? Are they getting the right type of coaching? An interesting thing too, Malcolm Gladwell, in one of his earlier books, kind of did this unpacking of hockey in Canada, and they found that most all of the professional players, in Canada, they go by the calendar year for school. So they were basically, if you were born in January, February, March, you had this advantage because when you're 6 years old, having 6 months or 8 months of growth is a huge advantage versus a kid who's just a few months younger than you. So I can also see this really helping parents understand, hey, is my kid getting the right training, the right attention, the route, are we leveling the playing field for everyone in this profession?
Yeah, Malcolm Gladwell always has some interesting takes on sports. And
yeah.
The only thing I'd say about that too, and I think we all would say this, is when you get into thinking about data and tracking people, at the professional level, there are agreements and the data is all agreed to. And I think as a parent of, 3 kids, 10 to 5, I wouldn't want their data just going out anywhere. So I think in every industry, we're having these discussions around ethics and data, and it's going to come up here in sports too. So that data should definitely be, owned by the person who it's tracking. And I think by and large, that's how things are being done. So the only thing I'll mention there is when you do get to the professional level where there are agreements that they're sharing their data, then you can do a lot of interesting stuff at aggregate. You probably lose that when you're just looking at your one person, like your own information.
I think that's a good point. There's 2 kind of thoughts with that as we're getting to more sophisticated wearable devices, with like microneedles that might be producing a vast amount of data on an individual, to where now you're collecting enough to get a lot of personal insight. But the other side, for today, we, as those devices are maturing, we have something called federated learning, right? Which is really important in healthcare. And that's the idea. If you have, in healthcare, the research groups are small, maybe 50, 100 people. If you have someone with 1,000 people, they think it's a really huge data set. And frankly, it's not. So you really need to compile from many, many different studies and have participation of thousands of people, right? Tens of thousands, hundreds of thousands. And the way they do that is with federated learning, to where there's certain aspects of the data that you can share, but you're not really revealing, who owns that data, right? So your personal identity is safe, except you're just opting in certain data points to help the data science team actually do something meaningful. So perhaps federated learning is an area where, your 10-year-old to 5-year-olds, where there are certain parts of their data that can get aggregated into a larger data set, yet you're still protecting their personal identity.
Yeah, I know we mentioned Strava before, but I saw a presentation at a conference, someone at Strava, and I think they do a really good job of having that opt-in option. So
Yeah.
you can choose to let them aggregate your data, and then you get some benefits back from that. You get to see some information about the aggregate. But they were talking about how they completely revolutionized the study on how people run on inclines and declines, because the previous experiments were done in labs on treadmills. And they had all this aggregated data on how people run it. It wasn't a linear function like it had been studied before. They kind of proved it was more of a curved relationship between incline and speed. So a lot of
That's
interesting stuff.
You know, because you brought up a good point too, Rob, right, with Strava, where you can opt in. You know, maybe we're getting to the point too where you can actually capitalize on it or monetize, right? So, hey, maybe I'll opt in on my data because there's going to be a value and I'm going to recoup some of that cost, right? So I'll give you more access to my data and my personal identity. And I could see that with rising stars, right? If there's, you know, a 9th grader or 12th grader that seems, hey, they're ready to go pro and skip all of college, I could see people wanting to have more access to that individual's data to kind of learn, is there something that's transferable to other athletes that they're doing?
Yeah.
But anyway, do we have another slide on NCAA, or we should move on to the NFL?
Yeah, so no, the next one's on the NFL. So this is a very similar thing to that basketball court plot where I created for one of the NFL competitions on Kaggle where they provided a bunch of data. I wanted to all see it on a field. So what did I do? I wrote a function to plot out the field so I could see all of the players' movements on the field. And
What place did you finish at in this competition again, Rob?
so this, yeah, there were NFL and Kaggle have done a handful of competitions together that I've taken part in. The most recent one, impact detection one, my team came in 2nd place, which is pretty exciting.
2nd place. That's why we call him the rock star around here. For everybody that didn't know, that is exactly why he's the rock star. So this is super interesting. So we see that you started out just kind of like the NCAA competition here, plotting everything else. So tell us about what you were thinking about here.
So this actually, there was a competition 2 years ago, I believe, that this was for, and they were looking at punts and how punts were returned and not returned. And I thought it would be interesting to normalize everything from the punt returner standpoint. So where are the other players when they receive the ball? And these two plots show the difference between where the other players are if they're going to return it, if they end up returning the punt, or if they have a fair catch. So you can see when players call for a fair catch, they're swarmed, they're covered by the defenders, not so much when they're returning it. And this kind of got at the question that I wanted to, in the story that I wanted to answer for that competition.
That's great. So it's a really fascinating view of the punt return.
And then I think this, yeah, this was one of the really cool things when I plotted. I was like, wow, I wouldn't have thought the differences would have been that stark. But on punt returns, you have the gunners, who are the guys on the outside that are just trying to run down the field and get at the punt returner as fast as they can. They could be single covered or double covered. Really good gunner will mostly be double covered. And I wanted to see how their pass changed if they were single or double covered. And that's what these two plots show. So you can see the arc of the way that they try to get at the returner is drastically changed when they're double covered.
Yeah, I was noticing how big that arc was compared to the single coverage. That's really, really interesting. Very interesting. Now, when I was, you know, a gunner in football, I don't know about you, Jeff, but I generally drew double coverage. So that arc was pretty wide for me. Any thoughts on that in your football career?
My football career was mostly Super Tecmo Bowl, Nintendo. So
run back and then throw it.
yeah, exactly.
When I made the
street ball.
It's funny you say that. When I made the plot for the field, all I was thinking about was Super Techno Bowl, because that's like,
that's what came to mind at first.
yeah.
Actually, Atari 2600 came to mind, but yours is much more sophisticated, so it definitely looked like the Super Tecmo version. So, I'm kind of curious, Rob. So, what kind of insight does this tell you, right? So, what should people understand that, when we're looking at the single coverage and the double coverage, now we can visualize this, what kind of decisions can be made?
So I think there's always going to be a jump between just taking the information as you see it and gaining insights. On that competition specifically, we saw that there were more injuries when there was double coverage. And then that leads you to ask the question, why? And when you plot it out, you could see that this trajectory plays a part in it. We don't know exactly how to quantify that, but when we see it visually, we can see, okay, the gunners are taking different routes that's somehow impacting how the game is played. So those sort of questions, I think, can lead the experts in the field, those that really know football and reviewing it, down paths of how can we make the game safer? How can we change, or how can we improve on how things are done?
So eventually this could lead towards a coaching decision on how to run a play. Right? How to better utilize your special teams depending upon various coverage models. So this is really fantastic to see. So eventually, as this matures, we could actually see this have a strong impact to mitigate, harm towards players.
Yeah.
So I think, Lenny, there was another slide after this that.
Yeah. So this is actually getting to the more recent, the competition that took place this past year that the NFL held, and they wanted to automate using video, the detection of any helmet impacts. So we were provided a handful of plays and labeled all the different head impacts from that. And my team ended up coming in second place. You can look at the next slide. It just gives a brief overview. This is where the Z8 came in handy, because I was running these deep learning models on a ton of data constantly to try out different ideas. And we used, our approach was to first identify every helmet during every frame of the video. And then we took just those cropped images of the helmets, and we fed that through a deep learning model with the previous and post frames for every slice. So you could think of the video as being sliced with all these helmets. And that ended up doing really well in the competition. And this is an area where deep learning, computer vision, those sort of things also have definitely a way they're going to make an impact in sports in the future. I think object detection has gotten so good that you can do a lot of interesting things just using the video data.
It definitely, that's really interesting. Go ahead, Jeff.
No, I think that speaks a volume of being able to just have that early detection of, whose helmets are impacting whom's, right? And where they're being impacted. That could help eventually in manufacturing better helmets for different positions. So it's really amazing to see this coming together. I know if you had Barry Sanders in that earlier clip with the Lions, no one would impact him because they can't touch him. But
yeah. That's Floyd Mayweather Jr. too, right? You gotta get hit. I gotta get hit before I could get knocked out, right?
That's right.
Yeah, so this slide is also showing that process that we use to make this deep learning model. It was a really fun, interesting problem to work on. But yeah, have been a lot of opportunities on Kaggle and just in general, data sets out there, sports related, that allow you to do so many different things. And it's been a great part of my data science journey, because not only am I working on something that improves my skills, but it's something I'm already interested in and questions that I'd already want to answer just as a fan of sports.
Yeah, I was wanting to ask what your fan level was with like NFL and different sports like that. So I think you kind of answered that. You're probably as big a sports fan as everybody on here that's watching this presentation right now. So you mentioned the Z8 helping you out with your Kaggle competitions. Are there any other key tips and lessons learned from these types of Kaggle competitions or other Kaggle competitions that have helped you within the sports world or within
So
this sports
typically,
kind of data science thing?
yeah, I think that I think typically on Kaggle, the competitions are, who can go up the leaderboard the best in making a deep learning or a machine learning model. But Kaggle also holds these competitions that are analytics based, where you're just making a report and you're doing storytelling and you're plotting data. I think that's also a great area to get involved in if you're interested in sports and data. But at the same time, I think that as a competitor, being involved in a competition, it kind of gives you that drive to continue to hone your craft and to see where you stack up against other people. So it's as a sports fan, it's also fun to compete in a way as a data scientist. That's what I like about Kaggle.
It's very interesting. Very interesting.
Yeah.
And
So yeah, the only, I guess your question was more along tips. Though I would say as a tip is just to get started on a project on Kaggle, and then it'll take off from there. There are a lot of always public things that people produce on how to start the competitions is always good to start out with, but then just read the discussion boards and ask questions.
yeah, I think your tip in the beginning, when we were talking about the NCAA as well as the NFL competition about trying to visualize the data first, I think that's a really, really big tip. I going through this presentation and looking at these different things as we've done before, that's what I'm really interested in is the different ways that you can look at the same data, and whenever you start to visualize it like that, how different your perception of that data kind of changes and stuff is always super interesting to me.
Yeah, I have a couple of questions. Not necessarily, this is not the Kaggle competition part, but from people who are listening that might be interested in furthering a career in data science and sports. If you have some recommendations or tips to anyone listening, how do they, become a data scientist in specifically sports? Is there public data that they have access to? Is there equipment such as, an HP mobile Z data science workstation? And what are your thoughts for those types of people?
Yeah, I mentioned this at the beginning, but I took a non-direct path to where I am now. So I think everyone takes their own path towards if they would want to get into, if they know that, if you're someone who knows you want to get into sports and data, then just start building up your resume, working on different projects is what I would suggest. There are a lot of data sets available, either ones that you can just download from different resources on the internet, but also Kaggle from all these past competitions. Mm-hmm. I think if you use them within the limitations of how Kaggle has them hosted, you can do a lot of interesting things. And it's awesome that that data is publicly available. So there's nothing really stopping you from getting started to try to look at that data.
Yeah, that's interesting. So what you're saying, Rob, is if someone wants to, hey, I want to switch my data science career to work into sports, I can go look at past Kaggle competitions. I can work within those parameters to see, hey, how would have I stacked ranks? So you don't actually even have to enter the Kaggle competition to understand how you can perform, right? So you can kind of take a gut check and see what your skills sit at. You can improve, and then you can enter this Kaggle competitions. And I think it's needless to say, if you start, competing well and placing, you have bright horizons, right? With a lot of offers. And that's the other side of the coin I'm interested in is, your thoughts as far as someone who's managing a professional sports team or even a collegiate, how important is it for them to invest in their data teams? What type of competitive advantage does it give them? We could look at Moneyball, right, as an early movie about data science, but really, why should people invest in a larger data team and a richer platform to practice data science if you own a team?
Yeah, I'm not an expert when it comes to the competitive side in terms of game theory and understanding how to use the data for a competitive advantage. But I will just say, as a fan, I have noticed that a lot of coaches that are adopting more advanced techniques, the ones that are ahead of the curve, are doing, it seems to be doing better. So I can just imagine in the coming years, this technology is becoming more advanced. Teams are learning how to adapt it and how to actually use it in a way that benefits their team. And once one team starts doing it and doing well, that's what happened in Moneyball, right?
Yeah.
Yeah, Angels did it well, and then everyone else wants to do it. So it's just a matter of time before teams start figuring out the ways to improve, and then everyone else starts jumping on.
So I think it's interesting, right? So let's say cross out the game theory side. I thought you brought up in your research, Rob, quite a few things that would make it compelling to expand a data team. One is you're looking at ways to mitigate, a player injury, and that's a huge advantage. So if you think about the cycle, if you're recruiting or deciding to go onto a team, where's the talent going to be attracted to? Are they going to be attracted to the teams that are taking better care of their players, that are running models, to developing plays to mitigate, the harm that they would have happen to themselves, that are investing in gear that's going to better protect them from concussions and so on and so forth. So I think just from what you're showing, there's a lot of reason to invest in data science teams and the tools that data scientists need to protect your players. And in doing so, you're going to have a competitive advantage.
Yeah, absolutely. Having a healthy team is a competitive advantage, right? So
yeah,
generally the healthier teams make it further into the playoffs and championships, right?
Well, yeah. For instance, some of these players get paid phenomenal amounts of money, right? Tens of millions of dollars. And the last thing you want to see is them spending a season on the sideline, right? And if you can have a model that can predict, if you run them on a certain play, that they're going to injure the hamstring, that they have a higher probability of concussion, that's very valuable too, just for managing, how you're spending on your players and making sure that they are in the game and not on the bench recovering.
Yeah, and I think there's always a balance too between the data side of things and then the professionals who are there with the players, and they know they know way beyond what I can know from looking at this data, right? So I see it more as having these data teams who can assist the professionals, the sports trainers, the coaches, the guys who are in this every day, and giving them the information that helps them the most, because everyone wants players to be safe. All the coaches want to succeed in their jobs. And it's just a matter of giving them this information in a digestible way, in a way that they can implement it and that can actually have positive impact on the game.
Yeah, I think that's a huge point, and something I know that Jensen covered in his keynote, and you're going to hear it if you're at GTC, is Omniverse, right? And it's a fantastic tool for really all domains. Primarily people are making movies in Omniverse, but when it comes to visualizing data, to your point, not everyone's going to read a plot graph. Not everyone's is a data scientist. They're not going to read the information the same way. So Omniverse is this really rich tool to where now you can start bringing in these data sets and these graphs and making it so you can visualize it. So now if you're a coach, you're someone who's never even heard the word data science, you can actually look and see what the data is telling you in a way you can make intelligent decisions. So there's an Omniverse tool. We also have Jarvis, which is a conversational AI, to where, once you start building these models and you're visualizing it, you could even ask and pose questions, right? So as you get this more rich, robust collection of visualizations from your team's performance, NVIDIA is offering many tools that can be loaded up on an HPZ workstation and allow people to make much better decisions in real time. So I thought I should give a plug out to Omniverse and Jarvis, because I see that as helping.
I'm really excited about Omniverse, Jeff. I'm glad that you brought that up. I'm really excited for all of the points that you just made there. I'm really excited for Omniverse, and I'm glad that Z by HP will be a part of that and be able to participate in Omniverse and definitely run that great software.
Yeah, it's really cool. I mean, there's things I'm working on climate as well, but if you think, in the future, we're going to have some sample models in Omniverse showing, what if scenarios. So now you think about places where there's inclement weather. What if there's a storm coming in, there's rain or there's snow? Could you run some what if scenarios on, who do you want to play? How do you want to use your special teams if, the storm comes in as a blizzard, or if it lightens up? And you can make some more informed decisions and actually visualize and predict, how your team's going to perform versus if it's icy, if it's snowy, if it's muddy. And so some really neat things coming together with Omniverse and data science.
Great.
So with that said, do we have any more slides on the show, or?
No, I believe that is it, Jeff. I think we got through everything, which is surprising. Generally, we don't do that. Generally, we're getting the hook off the stage.
Yeah, get swept off the stage here. Well, this has been a lot of fun, Lenny.
Yeah,
it's good to see you, like always, Rob. It was great having you on here. Thanks so much for everything you're doing to promote safety in sports with data science.
Thanks so much. I'm so happy to have been here. Appreciate it.
All right. Thank you, everybody from Z by HP and Future Tech, as well as NVIDIA. Jeff, Rob, it's been great. And with that, we'll say goodbye to everybody. Thank you.
Bye, everyone. Again, thank you, Future Tech. We really appreciate your sponsorship.
Yes. Thank you, Future Tech.
Cheers.